Let's look at the idea of magnetic flux. So the word flux has to do with how many things are passing through a surface, right? So given a surface, this is known as area vector. That's a line that is perpendicular to the surface. And we have to pick up the magnetic field or electrical field, or whatever it is. In this case, it's magnetic field. So here we have B, and we have to look at how perpendicular this is. How perpendicular the area vector is with respect to the magnetic field. And this will give us the magnetic flux. Now, flux can be positive or negative. Positive when we have the area vector and the concerned quantity, they have to be within the angles of, say, 0 degree to minus 90 degree to plus 90 degree. At 90 degree or minus 90 degree, they have a dot product which is 0. So this has to do with dot product, right? So basically this has to do with dot product. Again, I hope you guys remember, it's a very repetitive concept. So negative, if you have the area vector, say, in this direction by chance, and the magnetic field lines are in the other way around. Anything in this way also. So this being your scenario, then flux will be negative. Okay. Now, so this is a thumb rule when we have to how to handle scenarios wherein we have, say, a weird structure and we have magnetic field lines going this way. Again, it can be anything actually. So again, this is a quick revision. So idea of integration and everything. So say we have to figure out magnetic flux through this entire surface. What we do is we always start with a small section of the area. Right. So this is your, say, area vector. And this is your magnetic field line at this point. Say something like this. So what is that we are trying to do? Say we have an imaginary surface. And through that we have, say, magnetic field passing in this manner. Now the question is, what is the magnetic field line? What is the total magnetic field line passing through this? So what do you do? We divide the surface. First step is to divide the surface. Divide the surface. Then this is your first step. Second step is what? Figure out the field lines or the dot product. At that point, bunch of points. Fourth one is add them up. This is the entire funda. So basically, we will first do flux via a small surface dA. So we have d phi, which is equal to b cos theta dA, because it's a dot product and stuff. So if, say, this is b and this is your area vector, we have to take the dot product. In this case, it's dA. Does it make sense? So this is basically your dot product. Now, to figure out the total flux, so say we represent it in this manner, we have to take a dot between B and A, across the entire surface, my bad, across the entire surface. Okay, so this is a general thumb rule. So this we need to recall. Finally, we have the unit of flux. So it is Well, it is the number of field lines passing through a surface, so it would be so. Or there is one more named after a person, so it is small letter w. 1 Weber, if not VB. Again, it's a fact that you guys have to know, and this is quite simple. So magnetic field SI unit and the area is SI unit. This is magnetic fields, and that would be your areas. Then finally, dimension wise, so it would be let me think of it. That would be force, so ampere L square, yeah, something like this.